Okay, so 2.1, this is page 64. Page 64, 2.1 is translations. So this is talking about vectors, which I mentioned today. A vector is a quantity that has both direction and magnitude. And magnitude just means length. The initial point of a vector is its starting point, and the terminal point of a vector is its ending point. And we call this the pre-image. And the terminal point was the image. And here's your vector notation, okay? So remember, a translation is a transformation along a vector such that the segment joining the point and its image has the same length as the vector and is parallel to the vector. So let's look at an example. So if you flip the page, the top of the page here. Now, we were doing notation like this. Okay, x and y goes to x plus 4 and y plus 2. You can see that this moves over 1, 2, 3, 4, and up 2. So now we're just saying vector 4, 2, okay? And that's how that notation is made. So this means we're moving over 4, 1, 2, 3, 4, and up 2. And there is A prime. B goes over 4, 1, 2, 3, 4, up 2. There's my B prime. And C goes 1, 2, 3, 4, up 2. And there's my C prime. And you can see this is the same image. It's just been the same shape. It's been moved. And I made a little mistake here. I just noticed these, when you use vector, they're not parentheses around this. It's like little arrows, kind of a box, and that's what you use to when you're with the symbols for vectors, okay? All right. So let's look at the next example. And let's look down here at A. Okay, determine the components of the vector. So what is happening here? Well, the vector, it's moving 1, 2, 3, 4 down, right? So 4 down is a negative 4. And then 1, 2, 3, 4, 5, right, would be a positive 5. And so my vector equals 5, negative 4. All right, and so then, okay, so now we're on page 74. And this is 2.2 reflections. And these are reflecting over lines, which should help you with some of the work we did today. So there are perpendicular lines, which are lines that intersect at right angles. We have perpendicular bisectors, which intersect at right angles and also make the two segments congruent. And a reflection across the line maps point P to its image of P prime. So let's look down here at this first example. Now, if you look at this, there's several ways that you can do this. The first way is I can see that A is 2 diagonals away from line L. And so A prime must be 1, 2 diagonals away from line L. Okay? B is 1 diagonal, so B prime also has to be 1 diagonal. C is 1, 2 and a half, so I have a half, 1, 2, and there's my C prime. And I can do that. The other way is using slope. A is 1, 2, 3, over 3 and up 1. okay? So A prime is going to be the opposite, over 1, up 3. B is over 1, up 1, so B prime is over 1, up 1. C is over 1, 2, 3, and up 2 to this point. And so C has to be over 2 and up 3, okay? Remember, perpendicular slopes are what? They are opposite reciprocals, okay? And that's what we're doing. A was 3, oops. Up 1 over 3, and so A prime is up 3 over 1, okay? So that's kind of how that works, or you can just, let's look at another example. All right, so on page 75, let's look at 6. So the slope of this line, if I just find a couple of points on this line, here and here, the slope of line L, okay, I'm going to call it line of reflection, okay, slope is up 3 and over 1. So it means the opposite reciprocal of that would be -1/3, okay? So it means all my points are going to go down 1 over 3. I can see that, can't I? That was down 1 over 3 from that line. And then down 1 over 3, 1, 2, 3. And there's my A prime. Okay, down 1 over 3. I'm going to go down 1 over 3, and there's my B prime. Okay, C, you see, is down 1 over 3. So I'm going to have to go over 3, and there's my, and up 1 because it's on the other side, okay? And then there, oops, there is my figure, okay? So that's how you find, that's how you use just a line of reflection over any line. On the next page, there's some rules for reflecting. And you can memorize these if you want to, or you can just work them out. But across the x-axis, remember it's y that becomes the opposite. Across the y-axis, x becomes opposite. Reflected across y, the line y equals x. The x and y's flip places. And if you reflected across y equals opposite x, they flip places and become opposite. I want to do one more problem, and then we'll call it a day. So if you turn the page and you look at 12, okay, it says draw the line of reflection. Well, what do we know about the line of reflection? Well, it's in between, isn't it? It's in between B and B prime. It's right smack in the middle of A and A prime, and C prime. So what I want to do is find midpoint, okay? So the midpoint of B, let me write this a little different. Okay, so B prime, okay, line segment. The midpoint would be, this point is 1, 3. And this point is 3, 1. So I'd get 4 divided by 2 is 2, and 2. Excuse me. And the midpoint of A prime, A is -2, 4. And A prime is 4, -2. So I'd get 2 over 2, which is 1, 1. And then C prime, midpoint, is -1, -3. And this one is -3, -1. So the midpoint would be -2, -2. -2, -2, 1, 1, and 2, 2. And there's my line of reflection. Okay? And that's how you do that. So I will see you tomorrow.